Hello, every student. You must to go to the teacher's website and open today's topic. And today we will practice that our example is the chapter dash one. And for the objective of this is complete the full implementation of a deep learning classification problem and additionally include four procedures. The first is to automatically split the entire dataset DF into two groups, the training data train and the testing data test. The second is plot the historical loss value. And the third is evaluate the model's performance using evaluate, which return to value. Loss and matrix indicator. And the fourth is determine whether the model is overfitting. The method is overfitting. The error on the test set is much greater than the error on the training set. And the countermeasure one is to split the data so the proportional of the training data train is increased, e.g. to 0.8. The second countermeasure is to reduce the number of the neurons in the neural network. And we have the 7 introductory steps for deep learning nonlinear classification. We will build a model and configure three mathematical functions of the neural network model. And then we let the model learn and make prediction. And the fifth is a quantitative exam, the correlation between each visual column and the target column. And the sixth is how to quantitatively evaluate the quality of the classification model using evaluation. The seventh is check whether the overfitting occurs and compare accuracy trend. The objective of this task is using the Keras deep learning modules and build a neural network with multiple neurons as a nonlinear classification model in 6 introductory steps and use it to predict whether a patient has diabetes and make a prediction given a person A has the following feature value. So the first that we should to import that of all the data set. And now here we can find that in this data set, the Y is this column, whether the diabetes occurred. the features column is like this column. For example, this is for uh, the number of the pregnancy.
Number of pregnancies.
Or number of pregnancies. And for the second exercise, is split the original data set into train and test. Okay, finally we will do like this. And so before I do this, I will write this again by myself. Here that I use scikit-learn. I have a model selection. I call this as a MS, and I use the MS to do something. For example, that I want to make the train test split. Inside this, that for the I should to find that my DF. Here that is my DF. So the X value is like here. That is the DF delete this column. So the X column is the DF that I drop. A column code. Called what? Called this. And here this column is that the axis is equal the column. Before I do this, I can just do the test. Okay. And the second column, that is the Y. That is this is Y. And my test size, that is about 0.2. And after I do this, I will return many value Y train, Y X test, Y train, Y test. And finally, I will output the Y train. The totally that is the 537. Okay, that's because this is 0.3, right? Alright. And for the third exercise is 4 simple steps of a neural network model. Step 1 is build a mathematical model. So here that I want to build a model like here. And I use the unity that we have the neuron about the year 861. So for the first step that I write this by myself. I build a model that is use the deep learning, that is the TensorFlow. and I use the keras. Okay, I call this as TF, and then I build a model that is the model that is a TF TensorFlow keras. So I should to write this by myself. Keras, and then I find a sequential structure. And inside here, I will have a brain like here. I need to build a first layer. That is to use the TF dot keras, and then I create the tenor layer. That layer is a dense layer. Inside dense layer, I have the unit. I have ear bar, and I also must to set my input dimension. That is how many dimension that is mine. Okay, here is my 1 2 3 4 5 6 7 8. I have 8 columns. So inside here the input dimension that is 8. And I also use the activation. Okay, let me check that over here. Input dimension is 8, and the activation, why that I could not to input. Okay, let me find because it's too large, right? Why that I have something error? Is this right? Activation equal the value. Then I create next one. Next one unit is 64. This one is 1. The input dimension we only to do the first one. So I must to understand to find the reference for the activation. Since this is two labels classification problem, so the output layer activation of this is sigma. So I use the sigmoid sigma. Then I can just to execute the command. And then the next step 2, configure 3 mathematical function of the neural model, just like here. So before I do that, I just to insert a code cell. I copy the title of this and write here. Okay, student, you have 5 minutes to practice this until now. Now for the step 3, I want to do of step 2 to do this by myself. Here that I should to use the model, do the compiler. Inside this, I must to set the loss function. Loss function that I use cares the losses. I find because this is classification, right? So I must to find, since that is the just okay, let me find how to say of this. Binary classification. Since this is a binary classification problem, so the loss function that is binary cost entropy, and the matrix that is binary accuracy. The optimizer that is optim. So I use this as a cost entropy. The binary is cost entropy. Second is optimizer. If you just to use this, you can find that is optimizer, OPTI, optimizer, optimizer equal TensorFlow keras optimizers. I find that is binaries accuracy, binary accuracy. And we also have the matrix. That equal TensorFlow matrix. But not for this, I use the low case. I find the matrix is the binary accuracy. Okay, binary accuracy. But you should know the matrix because you can use a lot of the matrix. So inside this is a list. Okay, we have something wrong. It said that the y2 and y2 binary missing to binary cost entropy. Here that is binary cost entropy and also the okay. So because here this is algorithm, so I must to use the uppercase binary cost entropy. I think this is correct. Binary cost entropy. Okay, let me see. Binary cost entropy, binary accuracy. So the optimizer that is the update that is right. Losses that is binary cost entropy that is also correct. Matrix that is binary accuracy that is also correct. But why that you have okay, let me check. Well, okay, this is correct now. And so for the next step, third step that is train the model using the historical data. So I just to use of this to let the model to train the data here. And here that I use that model fit. I let train as train. and also one chain. And epoch that is the history. I have the just one. Okay, the 500 maybe is okay. And finally he will return history 1. Okay, let me see. Okay, we wait for do this, and I should to teach the next step for the he will do the predict. Step 4 make a prediction. I will predict this whether this guy have the diabetes or not, and he will just to okay. Now we want to make the predict of this one, and because that I have the model, I do the predict. Inside the predict that here that my data is like here this, but you know here the predict here you should have the uppercase of the X. So you could not just to use this, no, because this is horizontals. I should to use the data frame, and I transfer this into this. Okay, let this one to do the prediction. Here that I have completed the calculation, but something wrong. That is not correct. Right? The answer said that maybe I should to have the pandas as a PD. How about to put it like this? PD data frame, and inside here we just to transfer it into vertical one. Okay, the prediction is like here. It's very small, like 0. So because that the result is 0, so that is no diabetes. And for the fifth step is plot the historical loss data. So now I want to draw the map of historical, and I use the matplot library first. I use this to draw a plot. That plot is my historical one, and for the history data, and I plot of this. Okay, we have something wrong, right? Okay, he need to. So since that here you have the dictionary, you have this dictionary, right? So if you want to draw the map that you should assign which dictionary that you want to make a plot. Okay, I draw the loss. If I want to draw the other plot, that is the plot historical and history. That is a dictionary. Draw the binary accuracy. This is the other one. Okay. So maybe later I should just to to this is the orig, or, original one's the programming code of the original one. This is the original one. So since that I don't think that I should to do this. How about the use of that? No, I don't need to do of that. Maybe that I should do like that. So I just to plan of okay. That is very correct. I think that is correct. How about to copy of that to my practice one of here. Okay, that is quite the same, right? The same accuracy and okay, binary accuracy and accuracy. And since that here is this the accuracy of all the binary accuracy. So I think that loss trend, because that we have two values, right? Loss trend here is that is your, and which one that is correct? I don't think I think that this is correct. So is this the loss of the binary accuracy? So this is not correct. So maybe that is binary accuracy. That is correct. Binary accuracy. Maybe that is correct. Because that you are the history one, so I think that I should play that the loss will be plotted for at the beginning. Legend. And I must to check that here this is the binary. Okay, here this is the binary accuracy. So that is correct. That is binary accuracy. So how about to make a conclusion of this? And for the next one that you should do the quantitatively examine the correlation between each feature column and the target column. To quantitatively quantitative exam. So this I use the DF correlation, and I find that here is the correlations index. I can display the correlation value. Each column must have a numerical format. How to interpret the correlation of the features variables? So I can find that the possible outcomes of correlation coefficient. So that is correlation coefficient. 比较系它的相关系数 correlation coefficient analysis between two variables. So interpretation of the feature correlation when examine the target column whether the diabetes occurred, then the pregnancy that is a low positive correlation. For glucose that is moderate positive correlation. For the blood pressure that is almost no correlation. For the skin thickness that is almost no correlation. For the insulin that is a low positive correlation. For the BNI that is low to moderate positive correlation. For the diabetes pancreas function that is low positive correlation. For the age that is low positive correlation. Okay, now students, finally we will evaluate the model performance. Finally, we can just to output, we do the evaluate the trend data. You will output the loss trend and the accuracy trend. The accuracy is like this number. But for the test data, we also do the evaluate. The accuracy data is like here. This is smaller than this, right? So that is a overfitting occur. Since the test data accuracy is too slow than the trend data. Okay, student, you have the 5 minutes to practice this.